Today's agenda is that we need to understand what we call inter-process communication, which is purely handled by the operating system, because we are talking about multiple processes which are entities only known to the operating system as independent entities, and multiple of those entities are existing at the same time in the OS. If two of those entities, those processes want to talk to each other, they must use what we call inter-process communication. So today what we will be looking at, the first one is the pipes in Linux. So pipes come in two shapes in the Linux operating system. The first one is as shell command, and the second one is as system call, which you can use in C language. So before we look more into it, first let me describe to you how we can visualize what pipes are. So for example, for the shell commands of pipe, how we view pipe is that you have a program which is running over here. Let me call it process one, and there is another program which we are running. Normally in the shell mode, these are running one after the other. So let's say that process two is run after process one finishes running, and what happens is there is something which is called a pipe. So every program, normally shell mode, it generates an output, right? So process one is generating an output which we're sending to the pipe, and that pipe is receiving that data or the output from process one, and it is sending this output as input to another program. So this is what pipe is doing, right? So you can say this is the output of process one, and this is the input of the second program P2, right? So this is obviously something which is not an ordinary thing, a normal way of working of programs. So it must be something special, and it is. So let me show you an example in the shell commands, and here we have the terminal window. If, for example, I'm using a program called cat, and I'm going to type the name of a program, for example, message queue sender.c, and first I need to go to the directory where it is located. So the name of the program was messageq.c, msgq.qs.c. So this command cat simply concatenated the shell prompt with all the contents of that program. But here you can see that the contents are more, and they don't fit in one view of this screen or this display or this window. So we need to scroll up or down, which is obviously possible using mouse and cursor. But for example, your mouse was broken and you were not able to scroll using the mouse. What could you do? You could use a program which is called more. This is the name of a program, right? But these are two separate programs. Cat is one program and more is another program. So what if I used the keyboard to type this character, which is the pipe character, on the keyboard? You can see on the backslash key, you can use the shift key, and now you can access this pipe character. You can type it using your keyboard. So I'm going to, before the word more, because more is a different independent program, I'm going to type this pipe, which is a vertical line. We call it a pipe. Then I'm going to type more. Then I'm going to press enter. And now you see that after the first page was printed, which could fit in this size of the window, a new word more is written at the end, which was only possible because of the program more. So what happened was that the program cat generated an output which was sent through that pipe, which is this pipe character, to the second program, which is in this example called more. So now more took this input and displayed it in such a way that after first page is printed, you are writing here the word more. And now if I press enter key multiple times, it is taking me towards the next lines of this text file, right? So this is one example. So there's another example. If you use the program called less, this is another program. I'm going to press enter. Now I can use the arrow keys to scroll up or down this text file. I can read the text file using the mouse. I'm using these arrow keys on the keyboard, these arrow keys, these ones. And if I use the physical keyboard use the up arrow key, it goes up. Using the down arrow key, it goes down. The virtual machine is not accepting keyboard strokes from the host operating system. There's a setting for that. So when you reach the end of file, you can press the Q key to come out of this view. So again, what happened was that the cat program sent the output to less, the program called less, and less gave you a functionality to scroll through the output of this program cat using arrow keys, right? So that was the part of pipes which is in the shell commands. Now let's come into our the part that we are interested in, which is called system calls, the pipe system call in C. So I have an example for that. So let me open this program, and this program assumes parent-child relationship between these two programs. So in this example, I am going to use these programs in such a way that this is the parent program and this one is the child program, right? So now we don't use the pipe in the same way. We're actually using the pipe system call. So pipe system call model is different from the command line pipe which we just saw. So the pipe system call looks something like this. This is the pipe system call, right? It has two ends. So why I have drawn it vertically is the reason for that is because this is unlike the pipe that we saw earlier. It is slightly different than that. And there are two ends to this pipe. One of the end I am calling is the right end. This is the right end. And the other one is the read end. I'm showing the read end with green and the right end with red. So, and the thing with this model is that the role of both the ends, it doesn't change, right? So the role stays the same for both the processes. What I mean by that is, if process 1 wants to write to the pipe, it is going to use this end. If process 2 wants to write to the pipe, it is also going to use this end. This is just how the model is made, how the designers made the model. Similarly, if process 1 wants to read from the end, it is going to use this end. And similarly, if process 2 wants to read from the end, it is going to use this end, right? Process 1 wants to read this end, and process 1 and process 2 both are going to read from the same end, whereas process 1 and process 2 both are going to write to the same end as well. From the code point of view, obviously you know that there is going to be this pipe system call, which we simply write using this syntax, where you can see over here we are calling the pipe system call. So whenever we write something like this, it is calling a function. But here you see that we are using this p variable, which we're ourselves defining over here. This variable is an array variable or a list kind of thing, which has two elements. So this 2 is actually what? This 2 is the size of this array, and each element has type integer. So it means p of 2 is this array p is going to hold two elements. And how do you access these things? So p of 2 has two elements called p0 and p1. So this is how you access these elements. The indices, they go from 0 up to 1. For an array of size 2, the indices start from 0 and go up to 1. So my question to you would be, what would be the index limits for an array with size 100? The indices for an array of size 100 start from 0, they go up to 99, right? So yeah, so we are actually passing this array to this system called pipe, and in a way we are granting access to this pipe system call to make changes to this array, which it will. As soon as this line will run, pipe system call will be called, and if pipe system call is not successful, it will return a negative value and the program will exit. But if the pipe system call is successful, which means that a pipe actually gets created, you will see a positive value as a return value and your program will not exit, and you will come to this point, and these are the lines where I am showing the values of the numeric values of the identification number of the read end. So p of 0 is the ID of read end, and p of 1 is the ID of write end. So you can call this end as P of 1. You can identify this end, the right end, as P of 1. And if you wanted to identify this read end, you could identify it using P of 0. P of 0 is the where you will find the ID for the read end, and P of 1 will be, after running the pipe system call, P of 1 will contain the numeric value of ID of the right end of this pipe, right? So going back to the code, let's yeah, so here I'm going to print these things, and then after we have created the pipe, and by the way, up to this point of the code, before this line, or up to this point, you can say the picture is not like this. The picture is actually only this, because we have not created the child process yet. So at this point, we are using the fork system call. We're calling the fork system call, which is only this part, and not anything other than this highlighted code. Only the highlighted code is responsible for creating a new process. This part is simply receiving the return value of the fork system call into a variable that we ourselves created, which is called PID, which has type integer. So as soon as this happens, you're going to see this thing created, which is the child process. And now all of these things that you want to do can be done. But just to tell you a little info about what we are going to do, we are trying, the parent will, in this example code, the parent will only write to the right end, and the child process will never write to the right end, although it could, but it will not do that. Similarly, the parent process will not read from the read end, only the child process will read from the read end, although it could read from the read end. If the PID value, which is returned by fork, is greater than 0, which part is this, parent or child?
Parent, sir.
This will be the parent process. And the parent process, what it is doing is that it is writing to P of 1, which we set here, that P of 1 is the right end. And what it is writing is stored in MSD1, which we have defined over here as a string. It says hello world number 1. It is defined using character star. This is one way of defining strings in C. And then it is again writing the second message, which is hello world 2. Then it is writing the third message to the same. By the way, you may notice over here that P of 1, the right end, is used over and over again. And there is no handling of incrementing the pointer inside the pipe. So there is the operating system is stacking up different things inside the pipe, like these three messages. So if I had to show these in the picture, I could draw it like this, that for example, this was the first item. It would go over here, it would come over here, the second message would come over here, and the third message would come over here from the top. They're coming into the pipe, like first in first out kind of thing. And when we're going to read, it is going to pull out the messages, and the management of where the pointer should be is being done by the operating system and not by us. We simply keep on pushing messages into this right end, and they simply keep on stacking up inside the pipe as a constant of size 16. By the way, constants are simply a way of replacing some text inside your code in C. So whenever you start this, the compiler, before even compiling, will simply replace all the words MSG size with word 16 or number 16, right? So you are pushing in 3 messages of size 16 each into the pipe without taking care of the of the pointers or the managerial thing. So this is the first message, and then there will be the second message, and then there will be see the next thing. Then we will print that the parent has written to the pipe. Then we will close the right end of, because we are declaring here that we're done using the pipe, and we don't want to write any further into the pipe. And then we wait for the parent process waits for the child process to finish execution. While the child process, first of all, it closes the right end of the pipe, declaring to the operating system that for this particular pipe, this particular program only wants to read from the pipe, right? So if it closed P of 0, then child process would declare that it is only trying to write to the pipe. But in this example, we are trying to read, this program is trying to, the child process, sorry, is trying to read from the pipe. It closes the right end of the pipe. Then, by the way, this is when it will be running, this will be a separate program. All this code will be run as a separate program, which will be called the child process in our context. Here you can see that, by the way, these are things that I was just writing for delay, these two lines. So you can actually, try to ignore them. And for the rest of the things is that, in here what is happening in this line, the first thing, which is the first thing, so let me ask you guys, you have done a bit of programming, so in this line there are different parts, so you understand this, that there are different parts. Which part is going to execute the very first thing which is going to be executed? Kind of like operator precedence, if you remember. Basically, after collecting all of these things from the code above, the first thing that this line will be doing is calling the read system call. Because unless the read is being called, you cannot come up with the truth value of this condition which is inside the while loop to compare it with 0, right? So the first thing which will be done is calling the read system call. And read system call in here, what it is doing is, it is getting, or we are sending the value of the ID of read end of the pipe to this system called read, and we are mentioning how much data we want to read from this pipe. And when we have successfully read this size of data from this pipe, where do you want the data to be stored in your scope, in your program scope? So this inbuff, which we declared at this line, is an array of type character. It's a text message, you can say, which has variable name inbuff, and its size is 16 as mentioned over here. And so again, read system call is going to read from the pipe's read end message of size 16 and will bring it back and store it into the message buffer that we have created in our scope, which is called inbuff. When this happens, it is going to return a value. So not every function, some functions, they return a value. So that value we are storing in what we're calling n bytes. So n bytes is something which we have defined as an integer variable, and I've initialized it with some random junk value just to clear out a point that you will see shortly, right? So it is going to return a value which is going to be stored inside n bytes, right? So this value n bytes is the value which is essentially going to be compared to this 0 for being greater. And if it is greater, it means that you have successfully read 16 bytes, which will be returned into this variable. So you told the read system call that I want to read 16 bytes, and the read system call finished, and that 16 value was transferred as a return value to you, indicating that you asked to read 16 bytes, and I have done it, and you have actually read the 16 bytes. So if the value that comes as a return value is greater than 0, you continue the iteration, otherwise you go out the loop. So if you're inside the iteration, you first of all print on the screen whatever is there inside the buffer, whatever is being was read, all the 16 bytes that were read by the read system call into inbuff, you will simply print them out on screen. Just add some delay just for better viewing. And then what I've done over here is that I'm displaying the same value that we have read over here. And when all the iterations are finished, in the last iteration, it is going to try to read. So let me show you this step by step. So for example, we already had these 3 elements inside the pipe, and now the child process read this value out, and this value is gone from here, right? So and the return value you got was 16 because you have read 16 bytes. In the second iteration, you read this one, and the return value was again what? 16. In the third iteration, you read this thing, the child process read this thing, and the return value was again 16. In the fourth iteration, because we're not limiting the iterations here, so it will go for the next iteration. After ending this iteration, it will go back and it will try to check the condition for truth value. What will happen now? The read system call will try to go and read something inside the pipe, and it will not find anything inside the pipe. The pipe is empty. So what will it do? It will return what? It will return 0, which will break the loop, and you will jump out. You will not iterate, and you will simply, from this point, you will jump to this point. I hope this is very simple, right? And when you will print the value of n bytes again, you will see the value here at this point is 0. And that is what led you to jump out of the loop. And if for some reason you jumped out of the loop, and there was less, there was still some data in the pipe. You are checking that over here, and that should be an exit with an error from the program. And if not, then you will say that program finished reading all the data that was inside the pipe, and that is the program. So now I'm going to show you by running this program. So I'm going to type pipe parent-child.c. If I run it, it says, first of all, it says that p of 0 is 3. The ID of the read end is C. The ID of the write end is 4. And the parent has written to the pipe. And on the child process end, it reads the message, because if you look at the code, the parent never displayed this message. So this is only being displayed by the, and child process didn't receive it directly. It received this thing from the pipe, and then it displayed that in this iteration the value of return value of read system call was 16. In the second iteration, the return value of read system call was again 16. In the third, it was again 16. In the fourth iteration, the fourth time we called the read system call, the return value was 0. Therefore, we came out of the loop, and the child process says that it has now finished reading the pipe. So the programs, both the programs end, and yeah, so that's how one program is sending message to another program.